Hallucinations can slip through when no source document exists. SelfCheckGPT samples alternate answers and uses NLI contradiction scores to flag unstable claims sentence by sentence. You'll learn how the pieces fit into a workflow that flags unstable answer sentences by comparing them with varied model samples. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. If you are building question answering, summaries, or any output that looks authoritative, you need a way to know which sentences to trust. Zero-reference hallucination detection with SelfCheckGPT is not trying to prove facts against a gold source. It looks for instability inside the model itself. In practice, that means fewer surprises in production and a smaller human review load when answers drift or invent details. The intuitive idea is easy. Take one model answer. Generate a handful of alternate answers to the same prompt. Compare each sentence in the original against those alternates with an NLI style check. If many alternates contradict a sentence, that sentence is unstable and worth reviewing. Strengths: no external knowledge base required. Weaknesses: you pay for extra model calls, and any bias common to the model can persist. We will build a tiny pipeline that turns an answer into sentences, creates alternate samples, runs a contradiction scorer, ranks the riskiest sentences, and stores a simple experiment metric for comparisons. That lets you quickly see whether a prompt tweak made answers more or less stable. Quick note: this code is designed to teach the core idea clearly. Library versions and local setups can vary, so check the official docs if your setup behaves differently. Now, let us split an answer into reviewable claims and sanity check the count. This snippet turns one generated answer into the sentence units we will score later. The practical result is a clean list of reviewable claims. The code uses re.split to break the answer into sentence-like fragments, filters out empty pieces so sentences is stable, and reports claim count as a quick sanity check. That count matters. If your splitter glues or loses claims, the whole workflow will miss problems. So the visible output helps size the next round of model calls and plan latency. Splitting was helpful, but one sentence alone is not a verdict. We need alternate views to compare against. This example builds the cross-sample evidence set without needing a gold answer. In practice, it generates several independent passages and collects them into samples so you can see how the model varies. Samples holds the alternatives, and pairs enumerates the sentence-to-sample comparisons the pipeline will run. We aren't scoring yet. This step simply makes the evaluation surface explicit and repeatable. More samples smooth the estimate, but cost more calls. The printed count helps you balance budget and confidence. Now that we have claims and samples, we need a contradiction score per sentence to quantify instability. This code runs the real SelfCheckGPT NLI score over the claims and sampled passages. What matters is checker.predict. It takes sentences as the claims and sampled passages as the alternative generations and returns one contradiction-style score per sentence. So higher numbers mean less stability across samples. Device keeps the same code usable on CPU or CUDA, which makes the snippet portable across machines. The shown output is a compact score list you can store, rank, or threshold. Those numbers directly decide which lines move on to human review. Raw scores are useful, but a reviewer needs a prioritized list and a simple triage threshold. This snippet converts raw SelfCheckGPT scores into a triage list an experiment runner can inspect. The code sorts into ranked with highest contradiction first, so long answers point you quickly to the riskiest lines, then applies a threshold to produce flagged the subset worth human attention. Tweaking threshold trades missed borderline issues for review cost. and the snippet prints the top entry, so you see the single highest priority claim at a glance. That visible claim makes the next debugging step or prompt edit obvious. One isolated check is not an experiment. We want a repeatable signal across runs. This example turns sentence-level detection into a tiny experiment tracking signal. Rather than trusting one run, engineers collect len flagged across runs into history so they can compare prompt or model changes. Best picks a deterministic winner, so ties are stable between runs. The output shows which run had fewer flagged claims, and by how much, giving a small baseline you can use to guide prompt edits or model selection over time. Mapping this toy flow to a real project is straightforward. Use your application prompt and a small validation set of prompts. Run 3 sample generations per prompt as a starting point. Store len flagged per prompt and compare across prompt or model versions to see measurable improvements. What it is? A reference-free stability check that flags sentence-level claims by comparing alternate generations. When to use it? When you lack a reliable external source, but still need to prioritize review and reduce hallucinations. One caveat: it can miss errors shared by all samples and costs extra model calls. Try increasing samples from 3 to 5 and track len flagged across runs on your validation prompts to see whether disagreement stabilizes. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.